Hello guys, and welcome back to Study Star. Michael Mubanga, and in this video tutorial I'm going to be talking about factorization, part 3 of the algebra series. So, what is factorization? In simple terms, factorization is like bringing back the brackets, the ones we used to lose during expansion. So, say you've been given a number 3 plus 9x, and you've been asked to say factorize this number. So the way we go about it is we see what's common between the two numbers. So in this case, what's common between 3 and 9, or rather let me say, we find a number that can go in both 3 and 9 without leaving a remainder. So in 3 and 9, the number that can go there without leaving a remainder is 3. So we get our 3, then we open the bracket. Then the second step is we say this 3, we write the things as they are. Then we divide by this 3 throughout everything in the bracket. Then we say 3 divided by 3 is 1, plus 9x divided by 3 is 3x. Then just like that, we have factorized this expression. Let me give you another example. So say we have y plus xy. Then we want to factorize this expression. So in the same way, we find something that can be divided into y and xy without leaving a remainder. That's y. We write our y outside. We open the brackets, then we write y plus xy. Then we say y divided by y, and this same y, we divide it this side. So we have y 1 plus x, and that's us factorizing that. And this is the simplest form of factorization. It's the simplest way I could find. Okay. Then there's another type of factorization called differences of two squares. So we know that 4 is a perfect square. We know that 9 is a perfect square. 25 or 16, 25 and 49. We know that these numbers are perfect squares. So what is a perfect square? A perfect square is a number that has a square root. Okay, any number that has a square root is considered to be a perfect square. So in factorization, there's a topic we call differences of two squares. And the way we handle such things, so let me give you an example. Say we've been given 3 squared minus b squared, and we've been asked to say factorize this. So in order for us to factorize this, it's simple. We just get 3 minus b without the squares in one set of brackets. Then we open another set of brackets. Then we add. We put the addition sign. We put the addition sign instead of the subtraction sign, and that's how we handle something of differences of two squares. Now, in the exam or in a test, they don't come as simple as them already giving you something squared. The way they do it is they give you a perfect square and they say factorize this. So normally you would say that this thing cannot be factorized since there's nothing common between 4 and y. But in the case of differences of two squares, we just say what's the square root of 4? That's 2 squared minus y squared. This is the same, so 2 squared y squared. This is the same as 4. 2 squared is the same as 4. Then we say 2 minus y, 2 plus y. Then we have factorized just like that. Simple as that. Okay, so let us do another example on differences of two squares. Say you've been given 3x minus 12x squared. So what's the first step here? We find something that's common between 3x and negative 12. So 3x is common between the two things. So 3x over 3x, which is this 3x, minus 12x squared over 3x. this and this, this and this cancel each other out. We get 3x outside. This and this gives us a 1. Then x and x leaves an x. This and this gives a 4 minus 4x. So sorry guys, this was not the differences of two squares. This is just a common type of factorization. Okay, maybe we'll find something as time goes on. Okay, so this was factorization, the normal kind of factorization. We've learned about normal factorization and differences of two squares. Now there's a certain set of factorization that we call grouped factorization. So the way grouped factorization works is you will be given four different parts, minus 6by minus 4bx plus 3ay. Okay, so you've been given such, then you've been asked to say factorize this completely. So what we do is we find a letter that's common between any two of these things. So as we can see, a and x, b and y, these are not common in any way. So we find something that's common. For example, this thing, this 4. Minus 4bx minus 6by plus 3ay. So looking at this, we have x and x common here, y and y common here. So this is now grouped factorization. We have grouped them into the common variables. So what's common between these two things? We have 2 and x common. Then we say 2ax divided by 2x minus 4bx divided by 2x minus, we say plus. Never use minus, we always use plus for some reason. Okay, just use plus for now. We add the plus, then we say what's common between these two things. Okay, so looking at these two things, we can see that 3y is common. So after we see that 3y is common, we say negative 6by divided by 3y plus 3ay divided by 3y. Then we divide, we have this is a 2, this one goes, this and this is a 2, this. Then we have a minus 2b plus 3y negative 2 plus negative 2b plus a. Then as we can see, this and this are the same, so we get a set, we get one of these things, a minus 2b. Then we write the things that were outside like that. Then we have factorized using grouped factorization. Then the other way we factorize this, or another example is, say you've been given km minus 6ln plus 3kn minus 2lm. So we bring this side, we have km plus 3kn minus 6ln minus 2lm. So what's common between these two things? It's obviously a k. Then we say km over k plus 3kn divided by k minus 6. What's common between these two things? We have negative 2 is common and l. Then we say negative 6ln divided by negative 2l minus 2lm divided by negative 2l. So the k's cancel each other out here. Here this one becomes a positive 3. The l goes, becomes a positive here. The l also goes. So we remain with k m plus 3n minus 2l 3n plus m. Okay, so we can see these things inside are common, so we say m plus 3n k minus 2l. Then we have also factorized this. This is another example of grouped factorization. So when you go in the PDF found at StudyStar, you're going to find some more examples. So try them out. I'm sure by now you've got the idea. So I wanted this to involve factorization of quadratic expressions, but it appears I don't have much time. So this is where I'll end in today. Thank you very much, guys, for visiting StudyStar and for being so loyal and for following us on Facebook, also on YouTube. Yeah, Michael Mwanga. Thank you very much. Have a nice day. Oh, and I hope I'll see you in the next video.